The universe is vast, beautiful, and terrifying. Between the stars and galaxies, there exist places where the laws of physics begin to crumble. Where time slows down, where light disappears, and where even space itself folds inward. These are the monsters of the cosmos, black holes. They are born in fire, live in silence, and die in mystery. And yet, they may hold the most profound secrets about the nature of reality itself. Every black hole begins as a star. Not just any star, but a massive, burning giant that lives fast and dies young. For millions of years it shines, fusing hydrogen into helium, creating warmth and light. But eventually, the fuel runs out. When that happens, gravity takes over. The balance that kept the star alive collapses. Its core begins to implode, crushing itself inward with unimaginable force. In a heartbeat, the star's outer layers are blasted into space in a supernova, one of the brightest explosions in the universe. And at its center, what remains is something infinitely darker. A black hole, a point so dense, so powerful, that nothing, not even light, can escape its pull. Around every black hole is an invisible boundary known as the event horizon. Once something crosses this line, it is gone forever. No signal, no particle, no glimmer of light can ever return. To fall into a black hole is to fall beyond the reach of the universe itself. If you could drift toward one, at first you might not notice much. But as you draw closer, strange things begin to happen. Time itself starts to bend. To a distant observer, your movements would appear to slow down until you seemed frozen, suspended forever at the edge of the black hole. But from your own point of view, you would continue to fall, faster and faster, deeper into the abyss. The closer you get, the stronger the gravity becomes. Your body would stretch like a strand of spaghetti, pulled apart atom by atom in a process scientists call spaghettification. Inside that darkness lies the greatest mystery in all of science. Some believe that all matter that falls in is crushed into a single point of infinite density, the singularity, where the known laws of physics simply break down. Others think the core of a black hole might act as a bridge, perhaps connecting our universe to another, through what we call a wormhole. If that's true, then every black hole could be a doorway to somewhere, or something, beyond imagination. For centuries, black holes were only theories. When Albert Einstein developed his general theory of relativity in 1915, his equations predicted that such objects could exist. But even he doubted they were real. The idea was too extreme, a place where space itself collapses. Yet, decades later, astronomers began to find evidence. They saw stars orbiting empty points in space, moving faster than they should, pulled by invisible gravity. They saw light bending around unseen masses, forming halos and rings. Something was there, enormous, invisible, unstoppable. In 2019, humanity finally saw what was once thought impossible, the first real image of a black hole. Using a network of telescopes around the world, scientists captured the glowing shadow of the black hole in galaxy M87, 55 million light-years away. A fiery ring of gas and dust spinning around a perfect void. For the first time, we were no longer imagining the darkness. We were looking straight into it. And then, we found the one at the center of our own galaxy, Sagittarius A*. It sits quietly, 4 million times the mass of our Sun, hidden behind clouds of dust and stars. Every planet, every star, even our Sun, slowly orbits around it. The Milky Way itself spins under its influence. In a way, all of us, everything we know, are dancing around a black hole. It is the silent heart of our home galaxy. Black holes don't just warp space. They twist time itself. The closer you are to one, the slower time flows. If you could orbit close to the event horizon, a single hour for you might be years for someone far away. It's a natural time machine, built by gravity. But black holes also present one of the most haunting puzzles in physics, the information paradox. When something falls into a black hole, where does the information about it go? According to quantum mechanics, information can never be truly destroyed. But black holes seem to erase it from existence. This contradiction has baffled scientists for decades. Stephen Hawking once proposed that black holes aren't truly black, that they emit a faint radiation, now known as Hawking radiation. Over incredibly long timescales, this radiation allows black holes to lose energy, to shrink, and eventually to vanish entirely. But if they evaporate, what happens to the information they've swallowed? Does it come back somehow, or is it lost forever? No one knows. It's a question that challenges the very foundation of physics, a riddle that may hold the key to uniting gravity and quantum theory into one grand description of the universe. But perhaps the most fascinating part of all is that black holes, as destructive as they seem, might also be creators. When galaxies are born, black holes often form at their centers. Their immense gravitational power stirs gas and dust, compressing matter, triggering the birth of new stars. Without them, galaxies might never have taken shape. The energy they release while feeding, radiation, magnetic fields, jets of plasma shooting across space, helps spread the heavy elements that later form planets, oceans, and life. In a strange and poetic way, black holes may have helped create the very conditions that allowed us to exist. So, they are not just monsters. They are also architects, engines of creation hidden behind veils of destruction. In their hunger, they sculpt the universe itself. And yet, for all our discoveries, we still know so little. What happens beyond the event horizon remains unknown. Are singularities truly infinite, or does quantum physics stop the collapse before that point? Could black holes be connected, tunnels through the fabric of reality, or are they simply the universe's way of hiding its deepest secrets? Even today, we keep finding more of them. Stellar black holes formed from dying stars. Supermassive black holes at the hearts of galaxies. And now, we suspect there may even be tiny, ancient ones, primordial black holes, created in the first seconds after the Big Bang. Some could be smaller than an atom, others the size of planets. Invisible, silent, drifting through the cosmos since the dawn of time. One day, far in the future, black holes may be the last things left in the universe. When every star has burned out, when galaxies have faded into darkness, black holes will still remain, slowly consuming whatever is left, the final keepers of cosmic memory. And even they, after unimaginable ages, will fade away into nothing, releasing their last whispers of radiation into the cold silence of eternity. It's strange, isn't it? That the most terrifying things in existence, those that swallow light and crush time, might also be the most essential. They remind us of how small we are, how little we know, and how much more there is to discover. A black hole is not just a hole in space. It's a mirror, a reflection of our limits, of everything we still don't understand about the universe. When we look into one, we are really staring into the unknown, into the edge of knowledge itself. Maybe, one day, we'll cross that event horizon, not with our bodies, but with our understanding. Maybe we'll finally learn what lies beyond. But until then, black holes will remain what they've always been, silent, patient, eternal. The keepers of cosmic secrets, waiting in the dark. And as we gaze up at the night sky, seeing only faint stars and quiet light, it's humbling to know that somewhere, out there, in the infinite ocean of space, the universe is still whispering. Still collapsing, still creating. Because even in the deepest darkness, the story of the cosmos never truly ends.